You add enough people, it's going to turn into a normal distribution. If it starts out as normal, and then you add more people, so no matter what it starts out as, it's going to end up as a normal distribution. It's kind of like the law of large numbers again. The more you do something, the more it's going to end up as what it should be, which is a normal distribution. All right, now, let's look at a couple more examples. Have you ever gone to a kindergarten class and have to sit in those teeny little chairs? And you're like, you probably never thought about this, but I have, because I think about stupid stuff like this. Who ever thought how big to make a kindergarten chair? Just like, who ever thought how big to make a regular chair? Somebody had to think, how big do I make a chair? Now we're lucky for these because they go up and down, but somebody had to think, how do I know how tall to make it? How do I know how far from here to here to make it? Somebody had to think about that. You can't just randomly, because not everybody's the same height, but I have to make it a height that makes short people happy, tall people happy, but not everybody's going to be happy because there's some people that are really tall and there's some people whose feet dangle, but I've got to make a happy medium. Somebody had to think about that. So, this problem talks about that. It says, in designing new desks for kindergarten girls, there's an important characteristic that they must accommodate the sitting heights of students. The sitting height is the height of a seated student measuring from the bottom of the foot to the top of the knee. So, they are measuring from the bottom of the foot to the knee. So they're measuring from here to here, like where your calf is.
Is that with your foot flat?
Yes. So what they did is they found a bunch of kindergarten girls, and they measured from their foot to the back of their knee. Okay, so they needed to know how high to make it, because those chairs don't go up and down. So what they found out when they measured a bunch of girls is that kindergarten girls have a normal distribution with a mean of 61.2 and a standard deviation of 3.1. And they used that data to make the kindergarten seat. And somebody had to do that to make an adult seat. And they had to do that to figure out, okay, even for these, they had to say, okay, what am I going to use? Let me measure a lot of people. Let me do this to figure out what do I need to do to make the medium height? And then let me figure out how far I need to make it go up and down. Because they probably went out some standard deviations to figure out how far to make it go up and down. Because once they go up, they're like, okay, this is the normal mean, but if I go out one standard deviation, that's 68% of the population. If I go out 2 standard deviations, that's 95% of the population. So not only am I making the people happy at the mean, if I let it rant, go up, like see this one's all the way up. So if I go all the way up, I'm going to the right, and I'm making the tall people happy. And if I scooch it down, I'm going to the left, and I'm making the short people happy. So I'm making 95% of the people happy by just letting it go up and down. So these chairs are making more people happy than just the normal chair. Who would have thought? All right, so this first problem, and let me take this one right here and copy it, because we have 2 problems to do. Here's the first problem. This first problem said, what percent of individual means it is what it is. That means we're going to do it like 5.2. Sure you can see the rest of the problem. What percent of individual kindergarten girls have sitting heights greater than 63? So 63 is gonna be my data point. Is 63 less than or greater than 61.2? Greater, so I'm gonna put it like right there. I don't know where it's supposed to be, but I'm gonna put it somewhere to the right. Now, where am I highlighting? To the left or to the right of 63? So, here's gonna be that. So I'm gonna do the normal CDF of my lower limit, my upper limit, my mean, and my standard deviation. What is my lower limit?
63.
63. What is my upper limit?
999.
Positive 999. What is my mean?
61.2.
61.2. What is my standard deviation?
3.1.
3.1. Are we good? This is just like we did in 5.2. So I'm going to go to my calculator, not hit that, but hit that, and I'm going to do second bars. And y'all, when you get on your exam and you're like, crap, do I hit bars? Do I hit second bars? Remember the catalog lists everything alphabetically. So if you forgot where to go, you can go second catalog, second zero, and you're like, okay, I know it's normal something. So A, B, C, D, E, F, G, you can go all the way down to the ends. And you can scroll down and say, okay, it was normal something. Oh, there it is, it's normal CDF. So you can get to it through the catalog as well. So I'm going to do, but that one doesn't take you, it takes you straight to just the normal CDF without the plugging in. But it's going to be 63 is my lower limit, negative 99, no, Jen. 999 is my upper limit, 61.2 is my mean, and 3.1 is my standard deviation. So what percent of little girls are going to have a leg height that is greater than 63 centimeters? 28.1% of girls' legs are greater than 63 centimeters. Cool? All right. Now, this one says a group of girls. So now this is when we take a picture of a group of girls. So we have to, because it's a group, we have to redo the standard deviation. So the new standard deviation is the old standard deviation divided by the square root of how many people were in the picture. So, for our problem, what was our old standard deviation? Scroll back up. What was our old standard deviation? 3.1. So my old standard deviation is 3.1. Divided by the square root of 25 because there's 25 people in the picture. So I go to my calculator. It's going to be 3.1 divided by the square root of 25. So, when there's only one kindergartner in the picture, they look like they're 3.1. When you put 25 little girls in the picture, they look like they're 0.62. So my new standard deviation is a 0.62. We're not done yet. We just had to redo our standard deviation. You with me? Yeah.
Can you tell me where you punch the square root at?
It's right above the square button, and it's in blue. So you hit the blue button, and then you hit the X squared button. Good question. And then the X squared button. Good question. Now, we still have to do the normal CDF. So we still have to do this. Did the mean change?
No.
So my mean is still 61.2. My standard deviation is no longer 3.1. What is it? 0.62. Because we got a group. My data is still 63, and we're still doing greater than that. So what's my lower limit? What's my upper limit? What's my mean? And what's my standard deviation? So y'all, the only thing that changes, technically, if you don't want to write all that out, the only thing that changed was that. So, let me show you. Here's an easy way to think about it. When you're doing these problems, when I'm doing part A, is just going to be the left, the right, the mean, and the original standard deviation. So, let me write this twice, because y'all are fixing to do one, so I want you to understand what you're doing. So, part A, this is the original standard deviation. For part B, everything stays the same except this. You're going to divide it by the square root of whatever the group is. So, y'all, I'm lazy. So when I do this problem and I do second bars, normal CDF, so when I do it the first time, I'm going to do 63, 999, 61.2, and 3.1. And I'm going to get my answer, okay? And then when I do part B, I'm going to do second bars, normal CDF. The 63 didn't change, the 999 didn't change, that didn't change. Here, right in there, I'm going to do divided by the square root of 25. Right up in there in the guts. Am I killing you, kid? Now, if you want to do it on the outside, that's fine. But all you're doing is taking your original standard deviation and dividing it by the size of the group to make you skinny for the picture. All right, let's let you try one. I know you're not ready, but you're going to be ready. Assume that the weights of the men are normally, you have two questions. You have this question, individual men, and you have this question, a group of 36. Here, let me make it bigger. I see some old men in the back of the room. I ain't mentioning no names because there's only one old man in the back of the room. Just saying. Love you, Joe.
Love you too.
There's question A and there's question B. Two different answers. Whatever you want to round it to. don't care. My math does mean, so I won't be mean. One or two places doesn't matter to me. You do it so I can come around and check.
$69.1. There we go.
You done?
Mhm.
Me too. Yay, that's what I got. That's right. You done? You want to start with this one?
It's been a struggle bus week.
I know, right? It's been a busy week.
I'm just gonna slowly walk away. Pretend like I wasn't even there. At least get your math right.
Yeah. Oh, see, I don't have a problem with that.
This is biology. The struggle bus has run over you.
Yes. I'll wait for you.
That is the right one. The first one's the right one too. Both of your answers are right. And you even can't say it with the accent like she does. You got any answers? Your mean goes there. So it's low, high, mean, standard deviation. Low, high, mean, standard deviation. Low, high, mean, standard deviation. Huh? Okay, the lower's where you're shading on the left. The high's where you're shading on the right. The mean's in the middle, and the standard deviation is your spread. Yes! Yeah! Yeah! You ain't got none yet. Look. Where's your, yeah. You didn't put with the second answer. Yeah. No, you put with it. Point. Anybody else? Both of yours are right. Both of yours are right.
99.9.
You want to teach how to do this on a calculator?
No.
Okay. We have a normal distribution with a mean of 170, a standard deviation of 30. So we got that from the directions. Now, for part A, and what I'm going to do, not that. What I'm going to do is cover up so that I can show you that. Then I'm going to snag that piece right there because I'm going to use that same thing in B. So I'm going to put that off to the side for a moment. I'll put it down here. Then part A says we want, this is going to determine how we shade. We want less than 185. So 185 is going to be my data point. 185 is over here somewhere, that's my data point, and we want to shade less than. So when I do the normal CDF, I want the lower limit, the upper limit, the mean, and the standard deviation. Now, my lower limit, that's an L. My lower limit is where I shaded on the left. So it's like a number line. So where did I shade on the left? It's shading forever in the negative direction. So I want to think of the smallest negative number that I can possibly think of. What's the smallest negative number that I can think of?
-9.
So my lower limit is going to be -999. Not positive 999, Judy.
Oh, no.
Okay.
I'm
Now, my upper is where I shade on the right. Where does the last thing that I shaded on the right? 185. My mean is the 170, and my standard deviation is the 30. So when I go to my calculator, it's going to be second bars, normal CDF, and I'm going to do -999 to 185 to 170 to 30.
Yeah.
So my first answer is going to be a 69.1 or a 69.14 or something like that. I'll pull that back over in just a second. So my first answer is 69.1 or 69.14 or something. Now, for,
69, right?
yeah, that's what I had. My bad.
Yeah, I didn't want you later on when I printed up the one.
My fault. Okay, now for the next one.
This be before I start typing.
This is part B. So for part B, I'm still using the same stuff. Now we just have group data. So we have a group of 100 people. So we've got to redo the standard deviation. So my new standard deviation is going to be my old standard deviation divided by the square root of how many people were in the group. So my old standard deviation is 30 divided by the square root of
You have a
100.
different problem.
Yeah, the 100 isn't right. That's what I was just like, go on.
Yeah.
Yeah. 30 something.
My bad. 36. Now, what I did is nothing else changed because it's still asking me for less than 185. So everything else in the problem is exactly the same. I'm still doing less than 185. Less than 185. So it's still going to be from -999 to 185 and 170, but it's going to be 30 over the square root of 36. So what I did is I went to my calculator and I did second enter. Second enter recalls the last problem.
Oh, okay.
Oh! Mariana was like, oh, forgot about that. Second enter recalls the last problem. Then I backed that thing up and I divided by the square root of 36. Whoop, there it is. So this one is going to be 99.86 or 99.9, however you want to write it. Let's do one more again. One more again. This is X. Forgot Joe's in here.
My calculator came up like 96 when I redid that, and then it's got the lower is is negative 999, upper is 185, mean is 170,
Standard deviation?
yeah, the 30, and then,
I'm gonna come look at it. All right, come try number 11. There's an A and a B. Let me come look at yours. You didn't do divide by between 30 and the square root. Of course you did. I know, when you're looking at it, you don't see it. All right, number 11.
Yeah. Don't we need number 10 back here?
I don't know. Y'all?
Cause you deleted number 10.
Let's just call it there.
Y'all?
Cause I'm be trying to do this on too.
Okay, we're still using the same thing here to do number 11. My bad. I'm like, you're like, I don't know what I'm been using. Yeah, my bad. The good thing is that you know what you're doing to know that you don't have enough information.
Yeah.
Because in some classes, like biology, you may not know that.
I hate biology, man.
So see, the 170 is still,
Yeah, your 170 is still your mean, and your 30 is still your original standard deviation.
okay.
Whoop, whoop. I'm doing.
We're not.
Oh, Mills is doing. That was the first part. Yep. Yup.
Did I get the first one right? Before I move on to the second one?
It's a secret. Coming.
Is this one?
No.
Is this right? Or
Yeah.
does that be?
No. A says individual data. I'm still fat.
That's supposed to be.
That was B. Who else asked me? Brooke. B. That was B.
Oh my god.
Yeah, yeah, yeah. You with me?
Oh, I see.
Yeah. You were wanting to be skinny really bad. Yeah,
The
yeah.
second one is with the 100%. The other one is like the first one from the last one.
So to get A, you're gonna do second inner and back that thing up a little bit.
I think it's,
You with me?
I think so. I don't know. Is that?
That's A.
I'm still confused.
So I had them.
Backwards.
Okay.
Backwards.
Let me see right.
So you're not going to do the 100. You're not going to do the new standard deviation. You're going to do the old standard deviation for A, and for B, you're going to do the new standard deviation.
So would this not be B?
That's B.
Okay, that's what I asked. I don't know why I skipped A though.
That's what I just kept reading. I completely ignored the B.
Yeah. 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 Yes, ma'am. Woo-hoo, we got A. Are we feeling more confident? Until I yell at you and say, no, what are you thinking? Good job.
Okay.
Alright.
Yes.
I just skipped that first part.
I know. I know. I know.
I was like, how so like that's not
I
hit
was
backwards.
very upset when they did it here to me now.
I know, it's the other.
That's just redoing the standard deviation. You still have to do the upper limit, the lower limit. the me and that new student. Oh, yeah. Yeah. Yeah, you did. Yeah.
Do you say that at home?
What, y'all?
My daughter thinks I'm so stupid. She's like, Mom, do your students realize that you're as stupid as you are? I'm like, I think so. I think we stayed up last night and played Clue too much. I think that's. I took my dog,